Hi everyone, and welcome to the WebRTC Fiddle of the month. This time we're going to talk about ICE candidate gathering. This is something that we see many people get confused a bit about, so we want to try and make order in that yet again from a slightly different angle. Now, what happens in the call with WebRTC is that I need to be able to connect to you. And in order to be able to connect to you, there needs to be a connection. And that goes over IP networks, and IP networks are finicky, especially when we've got firewalls and NAT devices along the way. WebRTC uses a mechanism called ICE to allow it to gather different types of candidates, and then it will start negotiating to see which of these candidates stick and allow me to reach to you in that call. Okay, now before I let Fippo talk, let me share what I mean real quickly. So we've got three mechanisms in ICE, or three types of addresses. The way I see it are a bit, it's a bit more complicated, and we'll see that. But essentially, if I want to reach someone, the first address that I can use or want to use is his local address, the host IP address. If I can reach out him in that address, then I've got a direct link going to him. Okay, something like this. The second one is an address that I received from a STAN server. STAN server will simply tell me what is the public IP of that user. Okay, so I'm going to go to so our guy here will go to a STAN server, ask him for his public IP address. It will get a number, and this will be considered the server reflexive address of him. And now if someone goes to that address, the NAT device is going to simply pass that to me.
Not quite.
Okay.
I mean, what happens there is that you are sending to the STAN server.
Yes.
Which means you're sending a packet from the inside of your firewall to the STAN server, and then a packet from the outside that goes to that port can pass.
Yes, it creates a kind of a pinhole.
Yes.
Yes. Now, the third option when this doesn't work is to use a turn server, which is a full relay. That means that I'm going to a turn server, I'm allocating an actual address on the turn server that can be used to relay data to me. And then it looks something like this. So we've got different kinds of addresses, and we're going to need to gather them first in order to be able to run a call, essentially, or to make the connection running. So Fippo, to you.
Yes, so we have a small fiddle as usual. And we are pretty simple. So we have a form here for inputting the turn server or STAN server URL, a username, and a credential. So it's very similar to the WebRTC trickle ICE page, and it does exactly the same. And then there's a start button, which will start the process. And we have a log here for showing the output. Pretty simple so far. So when someone clicks on the gather button, it calls this function, disables the gather button, and then at some point later, it will re-enable it as well. And then it creates a set of ICE servers if the URL input is set. Otherwise, it's just creating a peer connection without any ICE servers, which works in some cases as well if you have only local networks. So we have that part here, which creates the RTC ICE server object. It's an array of objects, and that gets passed to the RTC peer connection constructor here. And then we have two callbacks on the peer connection. We could also write them using the add event listener pattern, which is slightly better in production because you can't have anyone accidentally unset your on ICE candidate. But we have two things here. On ICE candidate, which is called for every ICE candidate that is gathered, and some more, which is this part, which we'll look at a bit later. And we have the on ICE gathering state change, which is a thing that came into the spec at a later point and then wasn't implemented in Chrome until 2017 or so. And then what we do is we create a data channel, then we create an offer, and then we call set local description with that offer. And
why do we do that?
Because it's only when you call set local description that the whole process of gathering and exposing ICE candidates actually starts.
So the ICE candidates are actually being gathered before I even send the offer to the other side, the actual message.
Yes. I mean, this is the whole thing about trickle ICE. So you can either wait for all candidates to be gathered before you're sending a single message to the other side, or you just send your initial offer without any candidates to the other side, and then just as candidates come in on your end, you send them to the other side.
Yes, and we don't want to wait because waiting takes time, and time means connection time will increase.
Yes.
Okay.
For example, if you're waiting for related candidates to be gathered, that takes 2 round trips to the turn server. And if you have multiple interfaces, it will also time out, so it might take up to 15 seconds, and that's a long time to wait.
Okay.
So everybody does trickle ICE basically. So we're using a Twilio turn server, which is a good way to show things. So if I click the start button, it will start gathering candidates. And the first thing you'll notice is the candidate state change gathering, which comes from the on ICE candidate gathering state change. And that way we know, okay, things have started now. Then if we look at the timestamps here, you can see, okay, we're gathering host candidates pretty quickly.
And host candidates are my own local IP addresses.
Yes, it's one IPv6 here, one IPv4. We don't have the mdns.local because I've given JS Fiddle system permission to access my camera, which means I get IP addresses and not MDNS host names.
Okay.
And then what we get here is a server reflexive candidate, which is from the turn server.
And you this takes longer.
Yes, like 60 milliseconds.
Because I need to go to a server and back.
Yes.
Okay.
And then we also have a TCP candidate here, both for IPv6 and IPv4. And you can see the port is 9, which means, okay, the other side is just going to ignore that candidate because you can't connect anything on port 9. Also, it's an active candidate, so it's only saying, okay, I support ICE over TCP, but why do we even send you a candidate that you can't use anyway?
Yes.
Because the browser can't open TCP ports and listen on them for WebRTC. Native applications actually can do that. And then we have another ICE gathering state change to complete, which again comes from this function here. And then we have a candidate null here, which is basically the old way to say, okay, we're done with gathering. Yes, so this old stuff, you need to update your code at some point. It's not terribly important, but be aware of it. Also in Firefox, you have a candidate which has an empty string as the candidate, which is a per media section way of signaling the same thing, that you're done with gathering all the candidates.
So the best approach would be to sit on the ICE gathering state change and wait for it to be complete.
Yes.
Okay.
Then you can signal that to the other side, and then the other side does the same process with its answer and set local description and sends you the candidates back.
So what we've seen is we create a peer connection, we put the ICE servers in it, stun and turn, and then we let ICE gather the candidates. The way it does that is by going to the local host and going to the stun and turn servers, collect these addresses, and provide them back through the ONICE candidate messages. We need then to take these candidates and somehow send them to the other side, so they will know about these candidates. And when that process is done, we reach the ONICE gathering state change with complete. Okay. So thank you for this, Philip, and see you next month.